Hello. All right, so here we are for 0.5a substitution. So we have worked on solving systems of equations by graphing, where we're looking for that point of intersection. We have worked on solving systems of inequalities, where we're looking for like an intersecting space, kind of. But now we're working on not graphing, but an algebraic method for solving systems of equations. Can't think. All right, so substitution is a algebraic method for solving systems of equations, okay? Now we're gonna have two algebraic methods, substitution and elimination. So make sure you kind of highlight that this page of notes is for substitution. So the entry task today is just to correct yesterday's assignment, talk about any questions you have on that. And then I'm just gonna kind of have you copy this down and then I'll start handwriting all of the examples, okay? So just like when we were solving by graphing, we still have three types of solutions. So there's one solution, no solution, and infinite solutions. Now, if you remember when we were graphing, it was one solution was that point of intersection. So just like then, it's going to be a coordinate pair. So we're going to have an x, y coordinate for our solution today. But no solution and infinite solutions can be pretty tricky. And so please make sure you write this down very thoroughly to make sure you have it to look back at. So what's going to happen in both of these situations is all the variables are going to cancel out. And I have examples to show you, so you'll know what I mean by that. But you're going to be left with no x's and no y's. So if what's left over is a false statement like 0 equals 4, usually this one side's going to be a 0 and the other side's going to be a number. That is not true. 0 does not equal anything except 0. That is no solution. But if you're left with a true statement, 0 equals 0, 2 equals 2, negative 12 equals negative 12, anything where the two sides are the same, that is infinite solutions. Okay, it's hard to remember which is which, so please make sure you get this down in your notes correctly and you have it to look back on while you're doing your assignment. All right, so I'm going to move on. Go ahead and hit pause right now if you want some more time to write this down. Okay, here we go. So I'm going to do the examples. There are three examples, but they are kind of lengthy. So bear with me here. So example one. Oops. So we're always going to be starting with two equations. So the first one here is y equals 2x plus 5. And also we have negative 4x plus 3y equals 9. Okay. And then we put a little bracket around them just to show that this is a system. We're supposed to work with these together. Now I left a little gap here on purpose because example one is an example where one variable is alone. So when you look at these two, this equation here has the y off to the side by itself. This one, the x's and the y's are together on the same side. So this is what I mean when I say one variable is alone. The other thing is I always label my equations. And when we were graphing, we did y1, y2, but you can see that the y's are kind of mixed in here. So that wouldn't really work here. I just label them E1 and E2 for equation 1 and equation 2. Okay. So when you have a situation like this where one variable is by itself, step one, and I'm going to give you step-by-step instructions for a lot of these because I think that helps when you're doing your assignment later, is you're going to find the equation that has a variable alone. Now, one abbreviation I have, we're going to do a lot of writing today. And so I'm going to abbreviate the word equation to EQN. That's just the way I do it. So when you see EQN, that means equation. Find the equation that has one variable alone. So in this example, it's equation 1. And that one variable that's alone is this y. All right. So we found it. It's in equation 1. Step 2, we are going to substitute that into equation 2. Okay, so let me show you what I mean. So we're going to do step 1 here. I'm just going to write down equation 1. So that's y equals 2x plus 5. Now I'm going to write down equation 2. Negative 4x plus 3y equals 9. Okay, here's what we're going to do. Y is equal to 2x plus 5. Equals means the same as. So y is the same as 2x plus 5. That means I can use substitution. So the magic word today is substitution. We can use substitution to change any y that we see into a 2x plus 5. So I'm going to take this 2x plus 5 and I'm going to change that y into that expression 2x plus 5, okay? So let me show you what this looks like. I'm going to rewrite this negative 4x plus 3, but when I get to this y, I'm going to put a parenthesis and put 2x plus, close the parenthesis, and then put equals 9. Okay. So that's the trickiest part of what we're going to do today. So let me know if you have questions on that. I'm going to go ahead and move on. But when you're in class, be like, hey, Miss Waters, I didn't understand this part right here. All right, step 3. We are going to solve. So the whole reason we did this is because when we have an equation that has 2 different variables in it, we cannot solve that equation. It's impossible. Can't solve for x, can't solve for y. So by using substitution, now I have an equation that has only x's in it. Now I can solve this. So step 1 is going to be to distribute this 3 into that parenthesis there. So we've got negative 4x plus 3 times 2x is 6x. And then 3 times 5 is 15 equals 9. Then we are going to combine like terms. So this minus 4x and positive 6x are like terms because they both have an x on them. The 15 does not have an x, so it's an unlike term. So we're going to combine those together. Negative 4 plus 6 is 2. So this combines to make 2x. And then we still have that plus 15, and that equals 9. We haven't done anything with those. Now it's time to start moving things to the other side. So we want to get this x all by itself, which means I want to get rid of that 2, and I want to get rid of that 15. The first thing to do is get rid of the 15. So I'm going to subtract 15 from both sides. So 15 minus 15 is 0, so those are going to cancel out. And now I have 2x equals, and 9 minus 15 is negative 6. And then finally, I'm going to divide both sides by 2. And we get x equals negative 3. Okay. So at the beginning, I told you that when we get a solution, it's going to be a coordinate pair. So we just found the x coordinate of our coordinate pair. Oh.
GM lobby bathroom, please. Just going into the GM lobby bathroom. Thank you.
Sorry about that. All right, so the x coordinate of my answer is negative 3. So we've got half of it. Luckily, getting the second half isn't so bad. So the last step, step 4, is we are going to plug the answer into equation 1. Okay, so I'm going to do that here. So, all right, so equation 1, was y equals 2x plus 5. But I now know that x is actually equal to -3. So I can substitute again, substitution method, -3 in place of this x. So instead of writing 2x plus 5, I'm going to write 2 times -3 plus 5. So 2 times -3 is -6, and -6 plus 5 is -1. So the second half of my solution is -1. All right. So that is substitution. But I do have a couple of more examples. So let's go ahead and do example 2. So example 2 is going to have one extra step, but I'm going to go a little bit faster on this one because we've already seen all this like step-by-step process for solving, okay? So example 2, we have y equals -7x minus 3. And then we have -8x minus 8y equals 24. So that's equation 1 and equation 2. There we go. So I am going to do this one a bit faster. The first example, we wrote out all the steps. I took it pretty slow, first time seeing it, but I'm going to show you they don't have to take that long. So here we go. So we can see that this first equation is the one with the variable all alone. So I am going to write that down. So that is y equals -7x minus 3. And I'm going to write equation 2, -8x minus 8y equals 24. So my first job is I'm going to substitute -7x minus 3 in for the y of equation 2. So this is going to turn into -8x minus 8 times -7x minus 3 equals 24. Then I will distribute the -8. So that's -8x plus 56x plus 24 equals 24. -8x plus 56x is 48x plus 24 equals 24. Then I'm going to move the 24 over here. So 48x equals 24 minus 24 is 0. And then divide by 48. And we get x equals 0. Cool. So that means part of my solution is 0 comma something. Then we take this answer and we plug it back into this equation 1 here. So instead of x now, I'm going to put a 0. So it's going to be -7 times 0 minus 3. Well, -7 times 0 is 0. And 0 minus 3 is -3. So now we know that y equals -3. So I know I did that fast, but I just wanted to show you these don't take forever. The more practice you get with something, the faster you will be able to get it done. So I don't expect any of you to be able to do this example 2 as fast as I did, but I wanted you to see that the more you practice it, you can get faster at it, and they don't all take a really long time like example 1 did. Okay, so now I'm going to show you one where the variable is not alone. So examples 1 and 2, we had a variable all by itself, but example 3, we are not going to have that. So example 3, no variable is alone. And it's just going to be one extra step. So it's going to be basically the same as the first 2 examples, but you do have to do one extra step. So equation 1 is 8x plus y equals negative 22. And equation 2 is 4x minus 2y equals negative 16. Okay. So I am going to write the new step here. So step 1, pick which of the 4 variables would be easiest to get a loan. So let's look at the 4 variables. When I say the 4 variables, I'm talking about these 4, okay? So we want to get one of them to say x equals this stuff or y equals this stuff. And so I'm kind of thinking this through. If I wanted to get this x all by itself, I would move the y over here and then I would divide everything by 8. If I wanted to get this y by itself, I could move the 8 x's over here and then the y would be alone. This 4x, I would add the 2y and then divide everything by 4. And if I wanted this 2y alone, I would move the 4x over here and then divide everything by negative 2. So I noticed that 3 of them involve dividing, but this one, I wouldn't have to divide anything. And so the key to this is that you want to pick the one, and there will always be one. Pick the one that doesn't have a coefficient. Okay, the coefficient is that number in the front. So 8 is a coefficient, 4 is a coefficient, but this y does not have a coefficient. So I'm going to pick y in equation 1. Okay, so here's how I'm going to do this. I'm going to start by writing down equation 1, 8x plus y equals negative 22. So far the same as what we've done, but I just need to get this y by itself. I need to get rid of that 8x. So I'm going to subtract 8x from each side. And 8x minus 8x is 0. So now I have y equals negative 8x minus 22. So we were talking about like terms. These are not like terms. This has an x and this doesn't. So I cannot combine them. So I'm going to write them separately. Negative 8x minus 22. Now we're back where we started with examples 1 and 2. We've got an equation with a variable by itself. So now I'm going to switch to equation 2, 4x minus 2y equals negative 16. And just like before, I'm going to substitute. So I'm going to substitute this negative 8x minus 22 in place of this y. So I'm going to rewrite this as 4x minus 2 parentheses negative 8x minus 22 equals negative 16. So this went in for the y and turned into that. All right. Okay, so now it's time to solve. I'm going to distribute the negative 2. So 4x plus 16x plus 44 equals negative 16. The 4x and the 16x are like terms. I can add them together to make 20x. Then I will subtract the 44. Negative 60. And then divide by 20. So I get x equals negative 3. Okay. Now we are going to come back up here to where we had this y by itself, where we had y equals negative 8x minus 22. And we're going to substitute in this negative 3. So we are now going to write y equals negative 8 times negative 3 minus 22. So we have put this negative 3 in for the x. So negative 8 times negative 3 is positive 24. And 24 minus 22 is 2. All right, there we go. So that's our last example. But before we finish, I just want to reiterate something. And I mentioned this before, but all of these examples we had, these answers we got, are points of intersection. So if I were to graph these two lines, they would intersect at negative 3, 2. If I were to graph these two lines, they would intersect at 0, negative 3. And these two lines would intersect at negative 3, negative 1. So we're still finding those points of intersection just like we did when we were graphing. We're just doing it algebraically. So you can pick which way you prefer. Some people love algebraic methods because they really don't like graphing. I personally just would rather graph it, but it's good to have options. So this again was substitution. We are going to be learning another method called elimination. And part of your job is going to be to know which is which. Okay. So try to lock in your brain that we just learned substitution so that when we learn elimination, you'll be able to tell the difference. Have a good day.